We're asked to match these lattice energies with the three ionic compounds, iron 3 chloride, iron 2 chloride, and iron 3 oxide. So we can express lattice energy as a negative K, which is just a constant, times the product of the charges of those ions over the distance that separates those ions. And we just learned in our last video that it's the Q's that are a greater factor than the ionic size. And in all three of these ionic compounds, the Q's are different, the charges are different. So we can ignore the R because it's a minor factor, and we can ignore the K because that's just a constant. So let's just compare the Q's. All right. So for iron 3 chloride, because of the formula unit, we know that the iron was a 3 positive charge because chloride is always a 1 negative charge. We get Q's of 3 positive times 1 negative. All right, I'm just doing that part right there to get a relative lattice energy value. All right, so 3 times 1 is 3, or you can say negative 3 if you want. The next compound is iron 2 chloride. Right? I know that's iron 2 with a 2 positive charge because, again, the formula unit tells us the ratio, because chloride is always a 1 negative. These transition metals have oftentimes multiple charges, so we have to use the formula unit to determine it. All right, so the Q's are going to be 2 positive and 1 negative. 2 times 1 is 2. And then finally, iron 3 oxide. We know that the iron is a 3 positive cation because that 2 subscript from iron came from the oxide charge, which is always 2 negative, and its most stable form is 2 negative. All right, so the Q's on that one's going to be 3 positive times 2 negative. That's going to be 6. So the one that has the greatest lattice energy is going to be iron 3 oxide. So that thing is going to be there. And then iron 3 chloride is going to have the next greatest lattice energy. And then iron 2 chloride is going to have the smallest lattice energy. Well, when I mean smallest, I don't mean the greatest negative. I mean the least negative.